let's get to the method 2 critical value. So if you have your H0 distribution, how do you find the wiggle room? Well, you will get the wiggle room from the standard error. And remember that the standard error is something you get from SPSS or from Jamovi or from Stata. All of these apps are going to give you your standard error, or the software itself is going to give you the standard error, okay, based on your sample size. So if you have a larger sample size, it affects your standard error. We'll talk about that later. But let's say that we found a standard error of 0.51. Okay, so we plug that in, 0.51. Okay, that's the standard error for this H0 distribution. And it would calculate it from there. Deep breath. Awesome. Now, in this world of H0 distribution, we can find these things called the critical values, okay? So this is, again, a depression scale. It's going to show me how much you were impacted by using Instagram, right? It's the main number for the difference between people who use Instagram and people who didn't. This value, these critical values go from -1 to 1. How? How will they go from -1 to 1? Well, because we found this standard error, okay? 0.51, if you multiply that times 1.96, is going to give you exactly +1 and -1. You can do that yourself. You can do 0.51 times 1.96 plus 0 minus 0 is going to be +1 minus 1. Z-score class if you're struggling with this. Now, these are the critical values, right, in the depression scale. And the thing I want you to think about the critical values, which are literally the upper and lower bounds. We've been calling them the upper and lower bounds, but you can also call them critical values. They're often called that. The critical values, they work in a slightly different way. So this critical values method of checking if the number is 0 or not, in this world, we're not going to be using the distribution of the difference in depression, which is what we were doing before. Now we're using the distribution of H0, right? H0, the H0 distribution. The distribution of a world that has the null hypothesis as something truthful. In essence, mathematically, we're actually doing the same thing. I'm just showing you this because some teachers prefer to use that method, some teachers prefer to use the other method, and I think they're both very useful, and if you understand both, you're going to have a very clear understanding of statistics. So this is the most traditional way of doing things. So instead of using a distribution for this number 0.5, which is what we were doing before, we're just going to plug it in as the number of its own, okay? So this range goes from -1 to 1, and the 0.5 is there, and we're plugging in the 0.5 as a number that we just drew from the sample, okay? So let's say we're researchers. We drew a sample in which Instagram uses 5. No Instagram uses 4.5. So the difference in depression, for Instagram users versus no Instagram users after a month of use is 0.5. Okay, so we found that. Now, the question is the main number that we found beyond the critical values? You see, we're flipping the question, but we're still asking the same thing. Is the main number beyond the critical values? No, it's within the critical values. It falls in this region called the retention region, right? So we assume that the main number is coming from the world's 0 population, right? Does that make sense? We're assuming that this sample of 0.5 is not a sample that's giving us evidence that Instagram is awful, is going to kill us all. But we're saying that this 0.5 is probably a sample that we drew from that world 0 population, but we just were a little unlucky to find some people who were very prone to depression. But that's not that big of a difference, if you compare the control baseline 4.5 with 5. So we assume that this is actually 0 in the population, okay? This is clearly coming from the world 0 population. It's just some wiggle room. It's just some random error. It's not enough to say that it's coming from the world 1 population. So the critical values, they're too far from the edge. It didn't fall. What do we do in this situation? We retain the null hypothesis, right? So look, we're too far from the edge. So imagine that this is like a little cliff on both sides, and it's too far from the edge, so it didn't fall, right? So in that case, we can write it down. We retain the null hypothesis, okay? We're going to retain the null hypothesis. Let's look at this other example. So this is another sample, another study in a different parallel universe, okay? And now in this case, we have a depression of 6.5 for people who use Instagram and a depression of 5 for people who didn't use Instagram. Everyone was really depressed in this world. Now, The difference is 1.5 between the two, right? So let's plug that in. Is the main number that we found beyond the critical values? Yes, it falls in the rejection region, which is the region outside of the 95% range for a zero world, for a zero distribution. So you see what I'm doing? It's very similar to what we're doing before. So we assume that this main number is coming from the world 1 population. Probably, and the number we're going to assume for that population is exactly 1.5. So we're going to say, hey, let's say that there was a world 1 in which the population value was 1.5. Well, it's probably coming from that world and probably not coming from the H0 distribution, right? The most important thing with this 1.5 is not exactly that it's 1.5, but most importantly that it's not 0. It's a non-zero world 1. But we can use the 1.5. This is actually what we do use hypothetically. We'll never know if this is the actual value in the population, right? It's all hypothetical. All we can say is that this is a distribution for non-zero. It's very abstract, but it just means that it's a distribution for which the main value is not 0. Okay, so assume this main number is coming from the world 1 population, right? And if you look at the critical values, well, it went beyond the cliff, so it dropped. H0 is rejected. H0 is dropped. Okay? Oh, what a gratitude breath. So recap. Literally every test has a main number that we check if it's 0 or not using a sampling distribution, either through the confidence interval and checking if 0 is inside that confidence interval or the alpha one, or using the critical value.